Chemistry, this is another sample problem coming out of Chapter 7, Section 2. In this sample problem, we are going to use molar mass as a conversion factor in calculating the mass in grams of 2.50 moles of oxygen gas. And one of the first things you want to realize is that oxygen is one of the diatomic molecules described in Brinkelhoff. That's the mnemonic that lists all of the diatomic molecules: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So again, we see oxygen right there. So it's going to be a diatomic molecule. So it will not be oxygen, a monatomic. It will be O2. We want to keep that in mind. So the next thing I want to do is recognize that 2.50 moles of this O2 is the bit of information that the question has given me. So I will start with 2.50 moles of O2. And yes, I strongly suggest that you include labeling the species about which you are talking or that you're looking to convert. Now, my conversion here is going to be going from moles to mass. So the thing that connects both of these is molar mass. So I'll need to calculate the molar mass of O2. Looking at the periodic table, I see that the mass of a single oxygen atom is 16.00 grams per mole. But since I'm dealing with O2, I'll double that. And so the molar mass of O2 is going to be 32.00 grams per mole, per 1 mole. So I'm going to use this information as a conversion factor to convert from moles of O2 into grams of O2. So the next thing I see is I have moles as the unit given. I want these to cancel out, so I know for sure I'm going to move them down and diagonal, because that is the only way that we can get those units to cancel out, which is what I want them to do, because again, the answer needs to be in grams, not in moles. And so I have moles here. Again, I'm using this value in this conversion factor. I have my moles of O2, for how many grams of O2? 32.00 grams of O2 per how many moles? 1 mole. And now my crosshairs are ready to actually calculate. When I actually go to make the calculation and see that moles cancel out, leaving the only unit to be grams, which is a unit of mass, which is what the question asks for. And notice, if I set this up correctly and pay attention to the units first and worry about the numbers, the numerical portion, second or last, really, the setup will actually tell me what mathematical function to carry out. Again, don't want to hear students asking, do I multiply these two numbers or do I divide these two numbers? Because if you're asking that question, that means that you're skipping this most important part of actually setting up the calculation. Here, the calculation, the setup actually tells me what function to carry out. I'm going to multiply 2.50 by 32.00. I'm going to multiply those in my calculator. Again, if this 32 were flipped so that 32 was on the denominator, then that would tell me that I'm going to divide. But it doesn't. Okay, it's directly across from the 2.50 moles, so I'm going to actually multiply those values in the calculator. Put 2.50 multiplied by 32.00, and I get an answer of 80.0 grams of O2. Now notice I'm using multiplication as a mathematical function, and so in terms of considering the appropriate number of significant figures, I look at all of the values that I'm using here, 2.50 and 32.00, and I just identify which value has the fewest number of significant figures. I see that 2.50 has the fewest number of significant figures as 1, 2, 3. And so my answer needs to be reported with 3 significant figures, 1, 2, 3, and I'm good to go. So your final answer is going to be 80.0 grams of O2.